This is question 11. Let's practice our race as usual. Very long question with parts A, B, and C. Jason has 3 bags of beads. Do my first reading. He transferred 1/7 of the beads in bag X to Y. Then he transferred 1/7 of the beads in bag Y to bag Z. Next, he transferred 1/5 of the beads in bag Z to bag X. In the end, each of the 3 bags contained 48 beads. And then you have A, B, and C asking you about the number of beads in bag Z, in bag X, and then at first and then after the transferring. So you know that there's this story going on. There's this next, first, transfer, change, and then at first, all these things. So there is a sequence of steps, like a story. So how you can help yourself is, first, present the story out as if it's like a story in steps. You can try write down the steps, or you can draw a picture. Okay, so I did my first reading. Let me try to do my drawings as I do the annotation. So I have 3 bags of beads. 1 bag X, 1 bag Y, and 1 bag Z. Inside all don't know. This is at first. At first, nothing is being told. But I do know that, there's this in the end. So I don't know at first, but I seem to know that at the end of the story, there's this in the end. And in the end, it was all X, Y, and Z. They are in the end all the same 48. So if I can present this information for a start, honestly, not too bad already. You are getting somewhere. I don't know the start, but I know the end. Okay? Then work out the story again. Every time when you see this, when you see, hey, my information is my very clear information right at the end, that points me to one of the best way to solve this question. That is called working backwards. You know what I'm talking about? So when I look at the information, at the start, there's a lot of things going on, a lot of changes, a lot of things transferring. But at the very last part, in the end, is quite clearly stated the information. Each of the 3 bags contains 48 bits. So I have the last bit of information in the end. This shows that I can actually work backwards to get what's happening before. You know what I'm talking about? Okay, so let's figure out what was the story, the transferring that is happening. So first, there's 1/7, there's a fraction. So all these fractions, all these things are going to confuse you as well. You need to tell yourself, how am I going to make myself don't feel overwhelmed with so much information? So one way is I look at the numbers first. One way is I look at the story first. Take away the numbers, I just look at the English story. One way is I look at the sentence by sentence. Like reading a storybook, go paragraph by paragraph. Chunking. Yeah. So there are many ways but the only message here is to help yourself to feel less stressed about dealing with the question. Okay? Now, so I will focus on, because fractions give me stress, don't look at the fraction, I look at the movement first. So first thing, X go to Y. Oops. That was first step. Then, so this is step 1. step 1, x goes to y. Then step 2, y go to z. Step 2. That's step 2, right? Y to z. Then the last part here, step 3. Z go back to x. So x to y, y to z, z go back to x. Okay? Okay? So that was the movement. Then after you fix the movement, go back to the fraction. Okay? The first part, number 1, that was given was 1/7 of x given to y. Then the second one was 1/7 of y given to z. The last part, which is the most important part. Why is it the most important one? Because that's the one that you're going to first step to working backwards. The last step will become the first step to work backwards. And this last one was 1/5 of z. Okay? So the last step of the change was actually becoming the first step of how to solve. So look at the last step again. The last step says, I have 1/5 of z given to x. Now, looking at the question here, actually the question very helpful. It points you to see what's the number of bits in back z before transferring to x. It's actually helping you. It tells you to focus on z first. Right? Before transferring. So focus on z. So in the end, it was after transferring, right? So the key question right now will be, if I look at z now, how many units is this? Now, right now, after all the transfer. So the last step was step 3, right? He gave 1/5 to x. So right now, z will be how many units? 4 units, that's correct. Can you understand this part? So if you work backwards, the last step was taking part of z give to x. So if I were to work reverse, I give it back to him. So the amount that was given from z to x was 1 unit. The remaining was 4 units. Which means, if I look at 1 unit, how much is that? (48) divided by 4, that will be 12 bits. So the question is, originally in back z, how many was it? 5 units, right? So 12 times 5, 60 bits. So that's A. 60 bits. I work backwards. Now, then comes to this part. This 1 unit was what that was given at the last step to x. Look, question B, also very kind. See, it asks you, what was the number of bits in back x before adding the bits from back z? Can you see that? So actually the question very helpful. It just direct you to back to step by step, back to step 2, back to step 1. Can you understand? So at the end, x was still the same. Here, 48. So just now, say z give how many? So this part, 1/5 was 12, right? 12 bits. So if I were to say, okay, so what did it have before the transfer? Then my part B comes in. In the end, it was 48. Then minus the 12 that was given by Z. This is X before Z gave. So the second one, 36 bits. So whatever that was given, I take it away. Can you understand? So I work out Z, I work out X. The last thing, what was the number of bits in back X at first? That means at first here, I want to find this number. Then I need to work backwards again. Okay? Okay, so working back, I need to go back to steps number. Let's look at these steps here. That means I need to look at this step here that was given away to Y. So after X, give to Y, X is the same as before Z gave to. Can you see at this point is the same? So before step 3 happened and after step 1 happened, X the same number. You know what I'm talking about? So before Z gave, that was immediately after X gave to Y. So that's the same number. Meaning, looking at this one, this amount here, after giving 1/7 to Y, X has 6/7 left. And that was when Z decided to give 12 to it. So in other words, 6 units was 36 bits. So at first you are looking for 7 units. So 36 divided by 6 is 6. 6 times 7, 42 bits. Can you understand? So you need to understand, okay, so what is it happening? At this point, the last part for C, it was most important for you to connect that before Z gave something to X, that X at that moment was the same as the moment he gave after he gave to Y. So the remaining here was 6/7. And that 6 units was 36. Is that okay? Basic, okay?